Going on to topic 5 now of chapter 5, we're going to look at negative exponents and scientific notation. But to give you a little background, we had earlier said in topic 1 of this chapter, and you can use that reference sheet too, if you had a to the third over a to the fifth, and we were going to simplify that, why in division we're going to bring, let's say, the denominator up to the numerator. It changes its sign, that is, we're going to subtract, and we end up with a to the negative 2. But here they're telling us they only want positive exponents. So if we look here, we see a to the third over a to the fifth. How about, and remember there's a 1 in front of that, we bring our a to the third down, subtract it from the 5, and now we get 1 over a to the second. So positive exponents. So what do we have then? Well, that this equals this. So theoretically this is over 1, and by moving the exponent across the division bar, we just change its sign. Okay, so let's do some work on this now. Now it may take a little time, but let's just write it out. So we're going to have 1 then, stays up in the numerator, bring this down, 3 to the second, crossing the division bar, the sign of the exponent changes, and simplified, this is 1/9. Now when you see something like this, keep in mind the base of that negative 3 exponent is only the a. So this would be 8, that stays in the numerator, a to the third in the denominator. Now for something like this, all that would happen is you just reverse the signs. The y goes up as a positive 3, the x goes down as x to the fourth. Now this one's a little tricky. This is 1 over 4 to the second, which is 1 over 16, plus 4 to the 0 power is 1, and instead of writing 1, I'm going to write the 1 in this form, 16 over 16, so I can simplify this, so this becomes 17 over 16 as we prepare for the final. So we can do these together. We want only positive exponents. So remember there's a 1 there. So this would be negative 9, negative 11, subtract 1 then, negative 10. So this is a to the 10th, negative 10th, and that becomes then 1 over a to the 10th. Now here we don't have any negative exponents, but we're asked to simplify this. So 2 to the third is 8. X to the fourth raised to the third power is x to the 12th over x to the 15th. And when we simplify, we want positive exponents. 8 is left in the numerator. We bring this down, becomes a negative 12. So this is x to the third. Now we respect the signs when we're multiplying. So this will become x to the fourth, y to the negative 16. But we want positive exponents. So the x to the fourth stays up, y to the 16 goes down. Now here we can figure out what will be our n sign. Well, our n sign here will be a positive. fact, when we do this division, we get a positive 1/2. Now we're going to bring x to the second down, get x to the third in the denominator. We're going to bring y to the -6 up. That makes it a positive 6. So y to the third. This becomes a positive 6, -3 gives me a positive 3. Now, normally you wouldn't write the 1 here, so that when you put this in MATLAB, it would look like so. Now, if you did put the 1 there, I don't think they'd count it wrong, but I'd give you credit. Now, when we do this, notice the first thing you have to do is the parentheses. Please excuse my dear Aunt Sally. So you do the parentheses exponents. So this will be m to the second. Do this multiplication. This will be m to the positive 8. This is going to be m to the negative 10. And now what do you do? Well, this is going to be m to the 10th on top, and this is m to the negative 10. We're now going to bring that up, and this then becomes, as our final answer, m to the 20th. Now, when we have a fraction like so, and this is raised to a negative power, what you can do is just flip this over, which is what I'll do, 2x to the 4th, y to the 7th, over 3xy to the 5th. I took the reciprocal of that, and that then allows me to change my exponent from a negative to a positive 3. Now also, what you can do first is you can do some simplification inside here. This is all over a common parenthesis. So we're going to get 2 over 3. That can't be simplified. But here we have y to the first. Bring that up. I'm sorry, x to the first. This will be x to the third. And this x to the, or y to the 5th now, brought up can be a negative 5. So this is y to the 2nd. And now that's all raised to the 3rd power. So to change a fraction that has a negative exponent, take the reciprocal, just flip them, and the exponent then becomes positive. Do your canceling out since it's all within a parenthesis. And now we're going to raise that to the 3rd power. Well, 3 to the 3rd power is 27. 2 to the 3rd power is 8. And then we just multiply. X to the 9th, y to the 6th. And that's our answer. In this next example, we want to determine what will our n sign be. Negative 2 times negative 5 is a positive 10. Now we add our exponents. R to the negative 3. We can bring that, since there's nothing to add to it, we bring it right down to the denominator as a positive 3. S to the negative 2, we bring down to our denominator. Now this is t to the first, and this is t to the negative 4. So up in the top, a positive 1 and a negative 4 gives you a negative 3, but we want positive exponents. So it goes down to our denominator, and that's what we end up with. Now normally when you put that in MATLAB, of course the 10 will end up in the middle. Okay, so you'll have some practice and quiz me's on that. Now at this time I usually ask how many are familiar with scientific notation. Just raise your hand. Okay, and it's usually about half. So the lesson is, and if you were to read your textbook, scientific notation is something that we use where we place a number between 1 and 10 here times some power of 10. Again, that's raised to some exponent here. So we have to make this number a number between 1 and 10. So what we do is we get our decimal point and we just move it to the left. 1, 2, 3, 4. So we get a number 8.3 that we moved a big number over to the left 4 places, so it's 10 to the 4th. So take the decimal, move the decimal so it's a number between 1 and 10, and keep in mind how many decimal places you moved it. And if it's big numbers, that's the number, positive number, you raise your 10 to. All right, let's try it here. Gonna have a number 1 to 10 times 10 to what power? Well, remove it here. 1, 2, 3, 4, 5, 6. So that's 1.25, 10 to the 6th power. Now, big numbers are going to have positive exponents. Small numbers will have negative exponents because we're moving it to the right now. But the same thing applies. A number between 1 and 10 times some power of 10. But this will be negative because it's a small number. So 1, 2, 3, 4. So I have 1.54 times 10 to the negative 4. 1, 2, 3, 4. Very good. All right, same thing here. A number between 1 and 10, and then some power of 10 is going to be negative. Just have to keep track here. Let's see. 1, 2, 3, 4, 5, 6. Negative 6. 6.89. All right, so converting from standard form into scientific notation, or standard notation to scientific notation, this is how it's done. Now, for this, we're just going to add zeros to make it from scientific notation to standard form. So our basic number is 1.03, and here it is 8.7. Now it's going to be a big number because I'm going to raise it to positive exponents, and I need to have 6 places. Well, I have 2 here already, so I'm going to have to add 4 zeros. 1, 2, 3, 4. So when I move it, I go 1, 2, 3, 4, 5, 6. So there's my new number now in standard notation. And I can erase all this. It looks better. So how about this one? Now this is a negative 5. So actually I should write it over here, because I have to add zeros to the left. So I'm making it a small number, and I need 5 decimal places to move it to. So there's 1, so I need 4 zeros here. So I start to move it. 1, 2, 3, 4, 5. My decimal place goes there, and I usually add a 0 to anchor that decimal place here. take this one away and take these away here. Okay, now for this one, it's 6.003. Now I need 10 places to move it to. I already have 3, so I have to add 7 zeros. 1, 2, 3, 4, 5, 6, 7. And I just move it 10 places. And there's my answer. Take away this one. And this is 2.02, but I have to move it 3 decimal places. So there's 1. So I need to add 2 zeros. My decimal place is there, and I usually add a 0 to anchor it. And there's my answer. So not too hard. Sometimes it's a little tricky because you might do something and it's not quite in scientific notation. But let's go on to number 5. Now here as we do it, we're going to multiply this and get 54 times, and then we do this where we just add the exponents, and that's 10 to the 5th, 10 to the negative 9, which gives us then 10 to the negative 4. So we've multiplied, but keep in mind, is this in scientific notation? And the answer is no. The decimal is here. You would have to move it over there. Now, doing that, do we add a negative 1 or do we add a positive 1 exponent? Think about that for a moment. And the answer is we add a positive 1. We're making a big number smaller, so we have to add a positive exponent. Now, converting this to standard notation, we're going to add how many decimal places? And the answer is 3. So we have 5.4. We're going to add, we have 1, we're going to add 2 more, and it goes like so. And that is in standard notation now. Now, theoretically, you didn't have to put it in scientific notation. If you wanted to take this number, again, you'd move it 4 places, decimals here. So 1, 2, you would only have to add 2 zeros. And you get the same answer. Okay, now in doing this next one, here we're dividing. So 5 goes into 15 3 times. And we have 10 to the negative 2. When we bring up the negative 2, it becomes 10 to the 5th. So how many zeros do we have to add? How many places? Well, we have to move it 5. So there's none in a sense. So 1, 2, 3, 4, 5. Move it over 5. And there's our answer. Okay, by the way, this was scientific notation, and this is standard notation. All right, one more lesson to go.